Hello all, today we are going to be talking about how to factor trinomials when the a is greater than 1. So what that refers to is when we have a quadratic expression, a, b, and c are as follows. So when your a, which is this number 3, is bigger than 1, which it is, we're going to use this method. So it's called the AC method, which means you have to take your a and multiply it to c. So if we just list this out, we have a equals 3, b equals 11, c equals 10. So since I have a number in front of x squared, I have to multiply the 3 times 10 to get a positive 30. This number rather, is going to be the number you use to factor. So I'm going to start by listing out our factors: 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. And now we have to figure out which two numbers are going to help us make b. So in this case, it's going to be 5 and 6, both being positive. So this is where it really differs from factoring trinomials the regular way. So now that we have this 5 and 6, we're actually going to recreate this trinomial as a 4-term expression. Basically, remember when we multiply it out and then we have to combine like terms? Well, we're going to do that in the reverse way. So now we're going to keep this 3x squared in the front, keep the 10 at the back, and separate this 11x into 5x and 6x, because 5x plus 6x makes 11x. So it's kind of like we undid the combining like terms. So we wind up with plus 5x plus 6x plus the 10. Okay, now once we have this, and this strategy will be the same every time. You're always going to copy the first term, copy the last term, and separate this middle term into the two factors you find from the side. Now we have to do what's called reverse distributive property 3 times. So we're actually going to focus on the first two terms and figure out, well, what term that is exactly the same for both of these was multiplied to get these two terms. For example, 3 and 5, nothing is in common between 3 and 5. But x squared and x has an x in common, meaning I can do x times, 3x to get 3x squared, and x times 5 to get 5x. So I'm basically pulling out what's in common and putting it in front of a set of parentheses. So I'm going to have to do the same thing with the 6x and 10. So I need to think, well, what number is in common between the two? Well, the 6 isn't in common with 10. 3 isn't in common with 10, but a 2 is. So plus 2, and that means I had to multiply by 3x plus 5. These should be identical, okay? So now that I have two identical factors, I actually do reverse distributive for both. I can just copy out the parentheses that's in common, which is the 3x plus 5, and now everything that's left over goes in another parenthesis. So this x plus 2 goes here. And now we're factored. That's all. All right, so let's take a look at the next example. So for here, I have a equals 2, b equals 7, and c equals positive 3. So once again, I'm going to multiply this 2 times 3 because that's a times c. So 2 times 3 is going to get me a positive 6. List the factors. 1 and 6, 2 and 3. Which two factors are going to help me make 7? Well, 1 and 6, if they are both positive. So since they are both positive, I'm going to split this middle term into 1x and 6x. So we're going to copy the first, 2x squared. Going to take this 1 and make it a 1x. Take the 6, make it a 6x, and copy down the last term. Now I have to do that GCF, or reverse distributive property, 3 times. So the first time is for the first two, what's in common, an x, and I'll be left with 2x plus 1. Here, what's in common is going to be a 3, and what's left over is going to be a 2x again plus 1, because if I multiply this out, I'm going to get back to my original, right? So x times 2x is 2x squared, X times 1 is 1x, 3 times 2x is 6x, and 3 times 1 is 3. So now I have to do reverse distributive for the entire thing. So what's in common between these two sets? Well, the 2x plus 1, so write that out in front. Set up another parentheses, and what's left over, which is the x and the 3, go in your second parentheses. You are officially factored. So here are two more examples if you'd like to take a look at them. You have 5x squared plus 16x plus 3 and 6x squared plus 7x plus 2. Take a second to get them done if you'd like. All right, so for number 3, once again, we have an a equals 5, b equals 16, c equals 3. So I'm going to multiply a times c to get 15. 3 times 5 equals a positive 15. List your factors. 1 and 15, 3 and 5. So which two are going to help us make 16? Well, 1 and 15, again, if they're both positive. So I'm going to copy down my first, copy down my last, and split this middle term into its two pieces, positive 1x and 15x. Now I'm going to do reverse distributive for each set. So for the first two, the x again is in common, and I'll be left with 5x and a 1. In the second set, a 3 is in common again, and I'll be left with 5x and a 1. Once again, you could double check to make sure you did it correctly. Your parentheses should match, and also you can multiply to make sure you get these four terms. So now I'm going to find out what's in common between both of these sets. Well, the 5x plus 1, and a second parentheses for what's left over, the x and the plus 3. All factored. And here is our last example. So a is 6, b is 7, c is 2. So we're going to start by multiplying a times c to get 12. List the factors, 1 and 12, 2 and 6, 3 and 4. Two numbers that will help us make 7 are 3 and 4. So we're going to set this up, 6x squared plus 3x plus 4x, copy the last, plus 2. GCF for the first two. In this case, we do have a number in common as well. 3 is in common between 3 and 6, and so is the x. So what would be left over? Well, 3x times what gets me 6x squared? Well, a 2x. 3x times what gets me 3x? A 1. For the second set, there is a 2 in common, and I'll be left with 2x plus 1. Good thing, because that's what my first set of parentheses looks like. And now I have to find out what's in common between both of these. Well, the 2x plus 1. And what's left over is a 3x and a 2. And we are factored. Thank you so much for watching. Have a great day. Bye.